Okay, let's talk diastereomers. Someone was telling me they don't understand diastereomers. They don't understand between a diastereomer and an enantiomer. So really quickly, I have a separate video on enantiomers. So I'm going to be throwing out R and S. If you don't know what that is, you can go check out my RS video, and then you can come back to this one and also check out the enantiomer video. So for time purposes, in general, like if you have an enantiomer, right, let's say your chiral center is R, the mirror image is going to be S. If your molecule is RS, then it's going to be SR. Okay, it's a complete flip. With a diastereomer, you're going to have one chiral center that's the same. The rest can be different, but as long as one is the same, it is a diastereomer. In other words, if your configuration, the molecule is RS, okay, and then the other one is RR, the first R is the same, right? So if it was RS and it became SR, that would be an enantiomer. If it's RS and then it becomes RR, again, that's going to be a diastereomer because the first R is the same. Okay? So now that we know at least one chiral center has to be the same. Okay? Now, what is the rule? Because someone was asking me how many stereoisomers for a certain compound. The max is 2 to the n powers. So if you have one chiral center, it's going to be 2 to the first. You have a max of 2 stereoisomers. Again, if you have 2 chiral centers, then the max that you can have would be 4 stereoisomers because it's going to be 2 to the second power or 2 squared. So again, that's going to be 4. Now, that is your rule. That's the max stereoisomers you can have in that compound. Now, here's where my trick comes in. As you notice, all these molecules are extremely similar, but the chiral centers are changing and flipping. So let's figure out what they are. So let's look at this carbon right here. So this carbon is connected to a carbon that's connected to 2 oxygen. This carbon is connected to a bromine. This carbon is connected to another carbon, connected to an oxygen, and connected to another carbon. So again, your bromine is going to win. So that is going to be your priority 1. Now, this carbon is connected to 2 oxygens. This carbon is connected to 1 oxygen, so and a carbon. So this is going to be your priority 2. This is going to be your priority 3, and hydrogen is going to be your priority 4. If you look at the motion, it's going to be an S, so 1, 2, 3. But remember what I told you in my RS video. If your 4th priority is in front, that's going to switch. It's going to flip the configuration. So you don't have an S, you're going to have an R for this chiral center. Now let's do this other carbon. Okay, this is connected to an oxygen, this is connected to a carbon, this is connected to another carbon, that's connected to another carbon and a bromine. Again, your priority 1 is going to be your oxygen. Okay, this is going to be your priority 2, this is going to be your priority 3, and this is going to be your priority 4. Again, this is going to look like an S, but because your priority 4 is in front, this is going to be an R. Okay, so now that we found the configuration, now this is going to be extremely easy. Why? We know it's the same. This is COOH, this is your CH3, CH3, COOH. What's changing is your chiral center. This bromine is on the right. This is an R. This bromine is on the left. So it is going to be an S. This OH, this hydroxyl group is on the right. Now it's on the left. So again, this is going to be an S. Do you see how it was RR and now it's SS? This is going to be an enantiomer. Why? Because it's a complete flip. Okay, you went from RR to SS. It's a complete mirror image. Now, let's look at this one. Again, we already did the groundwork. This is an R here. This is an R here. It's the same. Now this OH, this R, the OH is now going to be on the left. So this is an S. This is a diastereomer. Okay, now what about here? This BR is on the left. This BR was here on the right. So this R is now going to be S. Again, your OH is now on the right. Your OH here is on your right. So again, this is going to be R. This is another diastereomer because again, one of them stayed the same. In this case, these R's, these R, and this R again is the same. Even though this S and R changed, at least you had one that was the same. In this case, your R here is here and your R here is here. This went from R to S, but at least you have this R that is the same. Again, if you enjoy this video and you enjoy this content, it takes time to create this, to draw these images and have it prepared for y'all. So please follow, like, share, and thanks again for watching.